Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will see how basic reg works and how we will improve. So in this video, I will not go deeper into how to implement a reg, but I'll assume that you know the basic reg and we'll see how to improve it. So let's get started. So first of all, just let me recap how this basic reg works, right? So first of all, let's see how reg will work, right? So what we have some documents, right? That document will be converted into chunk. That chunks will be converted into embedding, and that embedding will be stored into vector database, right? So this is the simplest ingestion pipeline, right? So now what will happen at the runtime, right? So let's say some user came, he asked some query, that query will be converted into embedding, and that embedding will be passed to a vector database, and we do a similarity search, right? It can be, let's say, a cosine similarity search, right? Based on that similarity, we'll find our top k chunks, which are very similar to this query. And those chunks we consider as a context, and that context will be passed to the LLM, and LLM will generate the final answer, right? This is a simplest form of reg, right? So in this video, what we do, we'll make our vector database as a constant. I mean, we will not change anything in the vector database, and we will not change anything into a generation pipeline, right? So we'll try to improve our retrieval, and we'll see what are the issues we can face and how to resolve that issues, right? So let's get started. So first of all, let me tell you what dataset I have used for this demo, right? So this is the dataset which I'm going to utilize for this video, which is Microsoft MS Marco. What it has a Bing search result. Let's say these are the query, and this is the expected answer, and there are some passages as well, right? So what we do, we convert this each passage. So you can see this is a passage list, right? So one passage will become a one embedding in our vector database, okay? And then we'll ask some similar question and see whether we are retrieving this passage which are actually required or not, right? So let's go to the VS Code and see this. So first of all, I did not use that whole dataset, right? I just use 2000 samples of that dataset. So if you see, I have this query, I have expected answer, and the query ID is that this query ID will match with the dataset query ID. Okay, so if you see this query ID 9652 has the same query ID here. I just converted those 2000 rows into a JSON for better visualization. And each chunk, this is 9652 underscore 0, that means this is the first element or 0th index element in this passage list. So it refers as a 9652 underscore 0, right? So same way I created a multiple questions here and related chunk which we want to answer the question, right? So let's see the retrieval process here. So here I use the Qdrant dataset, and I already generated a Qdrant dataset as I explained, and we will see our retrieval. Okay, so let's run this. So for dense model, what I use All-Mini LM L6v2 model. Okay, this is a sparse model. We'll see about this. So this is my dense search function. This will do basically find the cosine distance with our query embedding, with the embedding which are stored into the vector database, and return us a top k. Okay, here default is 5, but we can change it. Okay, so now let's see this query, Walgreens salary range, right? Or this is, let's say, ask this question. Okay, because we have created this golden data set which we will use to validate or evaluate our retrieval. Okay, so this is a Walgreens salary average, let's say. So I'll pass the same query here and see how it goes. So these are the documents which we got from our vector database. I just passed top k is equal to 10. So we retrieve a top 10 documents. Okay. So if you see, the 96520 is required to provide the answer, right? This chunk was required to provide this answer, and we got that as in our top k. It has the first position. It can be a second, third, but we get it our in top 10 documents, right? Which we will use as a context. So till now everything looks fine. We can provide the answer correctly, right? So this is how a dense search works. Simply, we convert our query into embedding using the transformer model or embedding model and find the similar embeddings into vector database, right? But here the one problem is there. This dense search use only cosine distance, or it use a semantic similarity, right? It cannot work better with where the query is related to a keyword related things, right? So let me show you something. So I have created some data questions which are related to hybrid search, which want basically. So let's say this query: what happened in July 5th, 2011, right? So we want this chunk to the answer. So if we do a dense search, let me just paste it here and ask this question. So what chunk we want? We want 11442_0 to answer this question, right? If you see, we don't receive that chunk here, right? If you see 1142, we don't get any chunk which related 11442, sorry. So we don't get any chunk here, right, related to this. But what happens here? Why our dense search or similarity search failed here? It is due to this query is highly depends on the keyword, right? We want a data related to a July 5th, 2011. So this does not have any contextual meaning, right? So let's say if you are asking about a brother and if you refresh it as a sibling, right? Those two things are very contextual similar. But here, this July 5th, 2011, maybe we cannot make it very contextual because it is a keyword based, you can say, or the date based questions, right? Here, the semantic search will fail. So if it fail, our LLM will not get the good context and we cannot provide the answer correctly, right? So that will be the first issue we can face. So now how to resolve this issue? So here to resolve this issue, you can think it like, okay, we can use a keyword based search, right? So if you use only keyword based search, right, you can get answer for this question, but the semantic similar question might fail where there is no exact overlapping of the keywords, right? So what we do here, we use a hybrid search technique. Okay. So the issue is we are not able to get the chunk which are highly dependent on the keyword, right? Not on the exact match, basically not on the semantic match. So we will use the hybrid search. Now let's see what is the hybrid search. In the simplest form, if you want, I can create a dedicated video to explain the hybrid search. But for now, you can think we will do a two kind of search. Okay. So if I explain you here, what we will try, we will first use the dense vector to find similarity, right? Which we did already and we don't get our result, right? But again, we will do that. Second thing we will do along with this is a keyword based search. Okay. So there are multiple vectors we can create which are keyword based, right? Let's simplest form, if you remember, there was a TF, IDF, right? This is one vectorization technique where we use keyword based technique, right? Not a semantic embeddings. The second algorithm which is very useful, which is BM25. I'm not going into much detail, but for overview of the hybrid search, you can think we do the dense search plus keyword search, and we have some algorithm, let's say a reciprocal rank fusion. If you want, please let me know in the comment section. I will create a dedicated video to understand the hybrid search. But We will combine them with some algorithm and we get our final top K. So what we did, we used the dense similarity as well, or semantic similarity, and the keyword similarity as well, and combining them based on the score, and we get our final answer. So this will resolve our issue where we need a keyword based search, right? So now let's see if we get this result in our hybrid search or not. So this is the hybrid search. So if you see, I have dense vector as well. I created a sparse vector using BM25, and then we'll search over the both and we'll make a fusion and get the final answer, right? So I created the same here. Now I'm asking the same question which we asked here. Okay, let's see what was happened. In July 5th, 2021. So if you see, we want this chunk to be in our top K, right? So if you see this chunk we got, it is not, of course, it's not at the top level, but in our top K, top 10 document, we get this, right? Because we also search for the hybrid search. So this date basically can be mapped or matched with our chunk which we have stored, right? So this, when we want to use the hybrid search, right, we want to update our ingestion pipeline as well accordingly. Our ingestion pipeline should have the sparse vectors where we can do a keyword search as well, okay? So now you can see by this technique, hybrid search, we resolve the issue where we are not getting a chunk which are keyword based, right? Now let's evaluate. So if you see, I have this data set where I have around 40 questions and the chunk ID which I want to answer that, and I expected answer. But here what we do, we will just evaluate a precision and recall of our retrieval with the hybrid search and with the dense search only. Okay, let's see. I'll explain what is the precision and recall at K in a while. Let's see just first the result. Okay, so now I am just reading this our data set. What it did, it will do a hybrid search and the dense search and check whether the expected document, these are the expected document, okay, to answer the question, are present into our retrieved result or not. Okay, let's see what we got result. Okay, so this is a result, okay, for 40 questions. So what it did, what it say, when we use the dense search, right, with top K is equal to 5, with top K is equal to 10, for top K is equal to 5 we get 0.18 precision and recall was 0.66. Same dense where top K is equal to 10, we get 0.12 precision and 0.77 recall. If you see, when we increase the top K, recall was increased but precision was decreased. I'll explain you. These numbers will look you very low, right? I'll explain why it's happening. But let's see for now. For hybrid search, when we use top K is equal to 5, we get 0.21 precision and 0.74 as a recall. When we use hybrid search with top K is equal to 10, we get the highest recall, right? 95, 0.95125. Okay. So now what this precision and recall says, let me explain that first. So let's see first a precision at K, right? So what it says, let's say my top K is equal to 10, so it will be at now precision at 10. Okay, so out of the 10 document which we retrieved, how many are useful, right? So if you see, you know, we are retrieving a 10 document, right? But when we see our expected chunks, right, so expected chunks are only one we want to answer this question, right? But we are extracting a top 10 document, right? So most of the question has expecting a one chunk. If we extract those one chunk, we can answer our question, right? There are multiple questions which want basically, let's say, 4 chunk to answer. There are some hard questions. If you see in my data set, I have created a difficulty level which can be hybrid and hard. So hybrid related question want the hybrid search to answer or get this chunk, and hard are basically question are generated from multiple question and we want the multiple chunk ID to answer that question, right? So if you see, there are some question which want more chunks to answer, right? But most of are related to one. So if we get one chunk which we want, right? Basically one chunk which we want. So in here, what we calculate in the precision, how many are useful out of what I retrieve. So actually, out of 10, only one is useful, right? As per the answer, because if we got this one chunk, we get our answer. So out of this 10, my 9 chunks are not useful, right? To answer that question. It is not the problem with our retrieval. It is not a problem even, I would say. But what is the issue? Because we want a smaller number of chunk to answer, that's why we are getting our precision low. So if we do precision at at 1, right, let's say 1, and we always get our that the document which we want at the first rank, then it will be 100%, right? But that won't be happen, right? So what we are doing, we are extracting top 10 chunk, but out of that 10, only 2, 4 or one document or one chunk is useful. That's why my precision is low. Now let's say what is recall, right? So if I say recall is simply calculate recall at k, right? Let's say I extracted a 10 document and I want let's say one document to answer, right? So k is equal to 10. My answer relies into one chunk only. So if this one chunk is present into this or not, okay, it's simply whatever we retrieve have the chunks which contains the answer or not. This recall will just calculate this, while precision will check how many irrelevant information also we are passing, right? So if you see out of 10, 9 was irrelevant to provide the answer, right? That why my precision was low. But while recall, this recall will calculate if we want a 5 document to answer, did we receive that or did we retrieve that 5 documents or not? Of course we retrieved, right? So after if we are retrieving 10 documents, almost 95% chances are there I will retrieve my documents which I want to answer my question, right? That's why my precision is low and recall is high. I hope you get the idea why here precision is low and recall is high. Okay. So if we use the hybrid search, we increase the recall much, right? So 95% recall is very good, I would say. Okay. So there are 95% chances I get my all the documents, or at least I get 95% documents for my question, right? So this is about the searching, right? Now let's see how we implement a reg using the hybrid search and provide the answer. Okay. I already have this code set up. I'll walk you through this. This is my collection name in the Qdrant, the same model we use here and the Qdrant, because we are using same vector database, right? So this is the hybrid search function. Here I'm just using the hybrid search, okay? Because we know hybrid search is providing a better recall. And precision will not make sense in this data set because we want very less number of chunk to answer, right? So now I'm using GPT 4.40 mini here. Temperature is 0 because we just want deterministic, or you can say less random answer, right? So what I did, I created one function where I will just pass my query, will retrieve a top 10 document using the hybrid search. Whatever the document or chunk we will receive, we will just combine it with the /n/n. Then that will be treated as my context, and that context I will pass here along with the query and ask the LLM to generate the answer using this query. If there is no answer in the context, just say I don't know the answer. Simplest form of reg. Okay, I'm implementing it in this way so you can know the concept. You can implement it in any framework using, let's say, LangChain, LangGraph, Crew AI. Multiple frameworks are there, but I am intentionally making it very simple so you can understand the concept. Okay, and at the end I'm just invoking the LLM, right? So now let's say I'm asking this question again. Okay, what was that question? Walgreens salary average. The same question is here, right? What is the Walgreens average salary range? Right? Let's say I ask this question, I got the answer 15,000, right? Dollar. And expected answer was a similar. So we get the answer. Same way we can ask for that query which is the hybrid. Let's see for that as well. I'm asking this question. And we got the NXP completed acquisition, right? So there are something NXP related answer we want, right? And we got the answer. So that is, till now we are good. Now there is one more case, right? Let's say you build this chatbot and you provided the answer about the Walgreens, like what is the Walgreens average salary range, right? Now, as a human, the next question, if I want to ask about the Walgreens, right, I will not mention the Walgreens in the most of the cases. If you, let's say you consider you are talking to a human, you know that we are talking about the Walgreens. So if you want to ask like how many stores Walgreens open, right, you will not ask like the whole question, how many store Walgreens open, because you already asked the question, what is the Walgreens average salary? So as a human being, in the natural way, what you will say? You will say, and how many stores it open, right? Let's see what happened in this case. So it says, I don't know the answer based on the provided context. Now what's happened here? Here we ask about the Walgreens. We did the hybrid search or contextual search. Let's say for average salary range, the contextual search will work better. But when we are asking specific about the Walgreens, the keyword search will work better, right? And we are combining the result and we got our answer correctly. But the next question does not contain anything, right? For what we need to provide answer? We lost our context here, if you see. The query did not mention whether we are talking about the Walmart or any other company and what we are asking, right? So here we don't get the correct context to answer. That's why our LLM says, I don't know the answer. So now, how to resolve this issue? To resolve the issue, we need to use a query rewriter, right? So what we will do, let me just explain you a simple way. So first user asks the question, what is Walgreens salary range? Okay, now you provided the answer. Now next question, immediate next question was, and how many stores it open, right? If you say the human point of view, it's look very easy or simple scenario, right? This can happen in a real world easily. So now here, how to tackle this? So if you see, this problem is not with our LLM. The LLM don't have any problem with this, and our vector database also don't have any problem with this. The problem here is how we are retrieving. So if you convert this query into embedding and search a similar vectors, right, you won't get anything. It does not mean we don't have our data into our vector database or LLM is not able to understand. The problem is we are passing this query. The query is the problem here. Query is not sufficient to answer, right? So what we can do here? The one approach to solve this problem is, what if we can rewrite this query, right? What does the rewrite means? What if we convert this query into, let's say, how many stores Walgreen open. So if you ask this question, you will get the answer, and if you pass this question to your retrieval or a vector database, right, you will get the related chunks. So the issue is not with our vector database, not with our LLM, the issue is with the query. So how to handle? So one thing we know, we need to refresh the query, right? So now based on what we can refresh, based on what we will refresh. So we need to utilize the previous query, or if I talk about the general term, we need to use a history, right, where it mentioned what was the context in earlier and what user is asking. Based on that, we can rewrite our query and search, right? So let's see how we can implement this. So here, the simplest thing, I implemented one function, rewrite a query, which will get the query and the history. History has basically a question and answer, okay? So what I write in the prompt, the first is, given the conversation history and user's latest question, decide whether latest question depends on the conversation history or not, right? So here it depends, right? Because we are asking the and how many store it open, right? What are the rules are there? This is the simplest prompt I can write, right? The prompt you can write in your way as well. This is the approach what I'm explaining to you, okay? So the rule is, if the latest question is already standalone and can be understood without the conversation history, written exactly as provided. So this is a very important line, okay? So what happened otherwise, this I'll explain you. Let's say you are asking this question, what is the Walgreen salary range, and this question you are asking second. So here that case will work perfectly fine because user want to know Walgreens open store, right? How many store Walgreens open. So this will work fine. But if you don't add that condition, like if query is standalone, do not rewrite, what will happen? Let's say you ask second question, instead of this you are asking some else question. Let's say what is temperature, simplest form, what is the temperature in any city, let's say temperature in London, okay? So what will it write? It can be rewrite the query as, let's say, what is the temperature in London and how many stores are open in the London, Walgreens open in the London, right? Because if you don't provide, if standalone query is there, do not rewrite, it will always try to rewrite based on the history, and we might end up with some wrong question, okay? That is also one problem. So whenever you use a rewriter or refresher query, you must add this condition, okay? It can be any, you can write in any form, but this is the simplest form I can write. The second thing, if the latest question depends on the previous conversation context, rewrite it as a standalone search query, right? So here it should write a query properly standalone, okay? It should not also contain some reference like eat, that, right? The third point is, the rewritten query must contain all important context from the conversation needed to understand the question, right? So this refreshed query should has the word Walgreens while rephrasing, right? So it should not miss any point. So this is the major point I would say to whenever you are asking about rewritten, okay? And other things you can write based on your use case, okay? That's fine. So here we are providing the history text and the query, and this function will just return a rewritten query, and then our flow will start, okay? So this is the function I created to manage the history. For the simplest form, you can, okay, so I use simple a list of here to store the chat history, but you can use any LangChain history, right? You can use the Redis, you can use SQL database, you can use in memory as well. For now, for simplicity, I just use the list, and what I will do, whatever the user is asking the question and answer, I will store here, okay? So if I'll show you chat history, I'm appending a user input, which is the human message, and the LLM response, which is the AI message. I'm just storing into this, right? And the reg, this will work simply as we did above, okay? Like whatever you are getting the context, just provide the answer, and chat history also we are providing here, and the LLM will generate the answer, right? So now how our flow will look here, let me just show you. So first thing is the user query. Okay, sorry. So first thing is user query. The query will be passed to rewriter. Rewriter will decide whether to rewrite the query or not, okay, along with the history. Okay, with history. And then the rewritten query, it can be a standalone query as well. Okay, rewritten query will be passed to our vector database, and then we'll get our top k. That will be our context, and that context will be sent to LLM. LLM will generate the answer. So we add this step here. Okay, the rest process is almost same, there is no change. We use the history and we add one extra LLM call, which is rewriting our query if needed. Okay, so let's see the same question here. Okay, so now I'm asking this, what is the Walgreens average salary range? We get our answer as it is. Okay, this is 1500. And if you see, the rewritten query is the same, right? Walgreens average salary range, right? We just remove this word, but that's fine. For to get our relevant context, this query will be enough, right? Now I'm asking the same question. Let's see, ask the same question and how many store it open. Okay. Let's use the rec chat here because it has the history, right? Now let's see. Yeah, so if you see, the rewritten query is now standalone and has all the information, right? How many stores has Walgreens opened, right? And we get the answer. Walgreens opened 184 new location in fiscal year 2014 based on our data set which we have, right? So this way we can improve our reg. Okay, so these two technique will improve your reg drastically. So this is what I want to explain you. Like whenever you don't get the correct answer, right, in a reg, if you are not getting correct answer, it's not a fault of vector database or LLM always, right? So basically, whenever you not get the correct answer, it's not like always it fault about the vector database and the LLM. Sometimes people change the LLM. Always the better LLM will not solve your problem. Okay, you need to check each and every pipeline. Okay, there are multiple things you can do, but these two major things I want to discuss in this video so you can get idea. Like always, LLM is not a culprit. We need to check our whole pipeline, right? So I'll create a more video about the reg improvement and the reg components. Okay, so please subscribe my channel and like if you like this video, and share it with your friends, and stay tuned for the upcoming videos. Thank you.